Hi, this is Derek Tsai from learnbyblogging.com. Today I want to give you a shortcut discussion on Bayes' theorem. I call it Bayes' theorem for practical thinker. I've been reading up on Bayes' theorem, as you might have noticed in the past blog, and what really gets me is how hard it is to think in practical terms for people without a degree in statistics or having resorting to very complicated math. Because Bayes' theorem or Bayes' inference is actually very important, very useful in our daily lives. I would like to share how I apply my shortcut using the simple. I want to share with my shortcut so people actually can calculate the probability using the simple 10-key calculator instead of a very sophisticated computer or program. So the best way to learn this is going to an example right away. Now, if you on the screen you will see the example that I show. 1% of women have breast cancer, therefore 99% do not. 80% of the mammograms detect the breast cancer when it's not there, therefore 20% actually miss it, and 9.6% of mammogram detect breast cancer when it's not there. The trick is to think of a base odd. So the base odd of getting a breast cancer is actually 1% to 99%. So 1 over 99. And then think about the evidence provided by the mammogram. And is actually only 80% to 9.6%. So the odd of mammogram picking up the right symptom or picking up the right disease or the cancer is 8.33 to 1 if you divide 80 by 9.6%. So the odd of having a breast cancer when you tested positive by mammogram are 1 over 99 times 8.33 to 1, and that came out to be odd of 0.084 to 1. Now you need to convert the odd to probability. Is basically you want to divide itself with additional number of 1. So 0.84 to 1 odd is same as 0.84 divided by 1 plus 0.84 equals to about 7.8%. So 7.8% of probability that if you detected positive by mammogram, it's a probability that you're going to have cancer. So the rate is actually pretty low by mammogram. You might as well, even toss a coin, probably do a better job. Example. Let's move on to the example 2. I know this is a sensitive topic for a lot of people. This more enlightening topic is Alan Downing is my favorite Bayesian statistic author and professor. I read up on a lot of his book. In his blog, there is one particular question. Elvis Presley had a twin brother who died at birth. What is the probability that the brother or Elvis is identical twin? Okay, very interesting story. I don't know whether Elvis is still alive to disclose it, but anyway, the facts. You need the following facts. Twins are estimated to be approximately 1.9% of world population, and the monozygotic twins or identical twin make up about 2.2%. So 8% of all twins are identical twin. So if you calculate the odd, the 8% of twins are identical twin, and 92% of twins are fraternal twins. So that the odd is 8 to 92%. And then this one, if that's the normal information were disclosed, that would be the end of it. But the more interesting part is that it mentioned that it was identical. It was a twin brother. So what is the probability of the odd of a twin brother versus a twin sister? The twin brother actually provide additional data points and that we need to take into account. and if you calculate the odd, there's 2 to 1 odd when that is going to be an identical twin if the same sex, right? So identical twin brother, a fraternal twin brother, to probability of fraternal twin sisters. So 2 to 1 odd, you need to calculate that. So you multiply the two odds together, you get this 0.174 to 1, and that if you converted probability, the 0.174 divided by 1 plus 0.174, that gives you about 15%. So interesting tidbit, something you can share at your party next time. The example number 3 is this last example also from Ellen Downey. According to the CDC, compared to non-smoker, men who smoke about 23 times more likely to develop lung cancer, and the women who smoke are 13 times more likely. Now, if you learn a woman has been diagnosed with lung cancer and you know nothing else about her, what is the probability, or what is the odd that woman is actually a smoker? So from the blog, there's one additional data point provided, is that 17.9% of women who smoke in the population. So the base R is actually 17.9% to 82.1%. So that is 0.21 to 1. Okay. Now the odd of women who smoke, the odd woman who is and then you need to multiply. You need to multiply that to the odd, which is 13 to 1 probability that women who smoke develop a lung cancer. So you multiply two odds together, you get 2.83 to 1. And 2.83, if you want to convert it to probability, is 2.83 divided by 1 plus 2.83. That gives you about 74%. So the 74% probability the woman is a smoker when she developed a lung cancer. So not very interesting. Well, not a very. It's very surprising actually to know the R is actually that high, and that's because multiplied by that 13 times more likely to develop a lung cancer if a person smoke. Okay, so hopefully that's more intuitive than just applying all this Bayes' theorem in a very complicated equation format. And you can go ahead and use this thing in the party to impress people. On the other hand, you might want to start calculating your odd. You want to calculate a chance of if you were a single man, especially in the Silicon Valley here, the chance of meeting a single woman, available woman, if you were a single man, is actually very low. Let's do the math. Let's say you go into a friend's party. Male friends' party tend to have more males than female. So you go to a party and turns out this person has 25% male friends and 75% female friends. So the probability, so the R is already 1 to 3, okay, that you're going to meet a woman. Now, what's the probability of females that actually, once it's a female, is going to be available and single, okay? Let's say the probability is 20% of females are available and are single and available, and 80% are not. Okay. Now you have base odd of 1 to 3 already. Now the additional odd of me finding somebody who's single and available is actually 1 to 4, because 20% to 80%. So that gives you, we multiply the two together, is 1 over 12. And that is not very good odd. It's calculated to be 7.7% probability. Now, let's say you are very selective, your company just went IPO and you have a lot of money, and you're more and you are just looks like Prince Charming, and you have very high selective in your way you select your woman, especially it has to be qualified and desirable, and let's say your R becomes 1 to 10. So it becomes, if you multiply the R together, you're going to be 1 to 120, and that calculates to be about 0.83%. So unless the party attendance is huge, going to be like 120 people or more, the probability, unless party is 120 people or more, you might have a shot of 1%, meaning 1%. Otherwise, you might as well just stay home and watch some basketball game, football game maybe. Probably more interesting, more productive. Anyway, hopefully that give you some idea, and hopefully that was helpful for you to think in terms of Bayes' theorem. And thanks for watching.